Okay, so in chapter 4, section 4, we're going to find slope and rate of change. Okay, so slope of a line. We've talked about this before. When you think of slope, you could also think of the mountains. People often talk about slope with mountains, right? We can think about the hill out here. Encinitas Boulevard has a slope, doesn't it? So when you are at the top, if you were on the top of Encinitas Boulevard and you were heading toward Moonlight Beach on your bike, that's kind of nice, right? And so we are going, how would you describe that? Downhill, right? Downhill. And so if we were going to give that a name like positive or negative, we would say that's negative, you're going down. And so how does slope change? Like if I'm going from the top of the hill down to Moonlight, traveling this way, right? Going downhill. We're kind of looking at what makes up a slope. So there are two things that go into it, really, right? It's how far you're traveling. What would you say are the two things that are making up the steepness of your slope? What do you think, Anthony?
Is it rise over down?
It is really. So it's how far you're traveling this way, right? Versus how far you're traveling this way. So imagine if I needed to get up to the height of that window, right there, and I started from where I am right now, I'm about what, 15 feet away from the window right now? The slope of me getting up there, you can imagine, is about like a 45-degree angle from where I am, right? But imagine I was trying to get my feet up to the top of that window and I'm from here, and you see how the slope is steeper? So what changed it? Because the window height didn't change. What changed it, Chris? Which distance was smaller? The height or the distance in the horizontal direction? Horizontal, the run. So when we have slope, we have two things to consider: the height, the y direction, and the run, which is the x direction. Okay? This kind of reminds me of the pyramids. Have you in 6th grade you studied the pyramids, right? And how did they get those heavy blocks way up high? They made what, Dylan? They made ramps. They didn't just go and say heave ho and lift it straight up, right? They used their knowledge of slopes to move these immense blocks up and around. I guess they went kind of around and around, spiraling up, in order to give them more of a chance of getting these heavy blocks way up high. They decreased the slope that way. Did they have to increase the distance, though? Yes. I mean, if they could have just lifted those blocks straight up in place, then it sounds really fast. It's just how do you do that without incredible machinery, which we do have today? The cranes that we have today can lift those types of things. So as Anthony says, slope is rise over run. And the letter that we use to represent it is M, right? Which, easy to remember, it's like mountains. Mountains have slopes. There's some math behind it. So I've already said the rise has to do with which axes, the x or the y, everyone?
Y.
The y. So it's the change in the y direction between 2 points over the run, which is a change in the horizontal, represented by what letter? X. Okay. So as we saw before, look at this is a point. X under y. And then we have another point, x under y. The reason you have the little subscript 1 here is to show that this x goes with this y. Do you see that? It's a named point. We identify an actual point on the line, and we just call it the first point, so x1, y1. And then we name another point. We find another exact location on the line, and we give it this name, so you can see the difference. Okay? It would be wrong to place x1 under the y2, wouldn't it? This must be a point. X under y, x under y. Okay? Must be actual locations on your line. So another way to say this is that we have a change in the y direction over a change in the x. And you know, a little triangle can be a shorthand way of saying change. What is the change in the y over the change in the x, given 2 points? There you go with it in words. So just change in y over change in x. Isn't it nice that in math we have so many abbreviations, shorthand ways of saying things? It's nice. So let's find the slope of this line. This line is a graph for you. You can see it. And we actually have 2 points that are named. There will be questions where you are given a graph and you have to go locate 2 points on it. And there may be a lot of choices for you, but you just simply need 2 really clear points on your line. So how do you find 2 really clear points on a graph? What do you look for so that you can identify these numbers here? Sophia? You could find x and y intercepts. As I look at this line, it looks like the y-intercept is somewhere between 0 and -1, so that's not very clear. So I probably wouldn't use it here. And of course here we'll use what they gave us because it's like a freebie. They gave it to us. But how else could you locate 2 points?
When the line goes across somewhere in the corner.
Very good. Yeah, you're looking for an intersection of 2 of the graph lines, right? So that you can see a really clear point that could be named. So, okay, but in this case, we're given these 2 points. There's this nice graph. So we'll start with our formula for slope. So write it down as often as possible so that it is really in your mind how to find slope. So let's say together, m equals
y2 minus y1 over x2 minus x1.
Good. Okay, so which point shall we call, well, already in this figure we see a point has been named point 1. Do you see that? You really could name either point 1. It doesn't matter. Isn't that interesting? There's no way to go wrong. You can choose to call 6, 4, point 1. This says x1, y1. Or we could call this one point 1. And we'll try it both ways so you can see that. Okay? Since it's labeled right here that this is point 1, let's call this one x2, y2. It's just a way to name this point. Okay? So when we plug it in, who can tell us how these values will substitute into this formula then? Lindsay?
-2 minus 6.
Okay, -2, we have the y, right? Minus 6,
Oh, it's,
you're subtracting an x there, so what do we have to subtract?
Minus 4.
Good. Over.
-2 minus 6.
Good. So before we even do the math, let's go check to make sure that we have a point that's stacked up. -2, -2, x, y. Yes, this is a point, -2, -2. 6 under 4. 6, 4. Okay, so we do have correct points placed as they should be placed. This is subtraction, so what can we change it to? Let's do that. Add the opposite. Add the opposite. And -2 plus a -4 is? And -2 plus a -6 is? -8. So a negative divided by a negative is a positive. And a 6 over 8 could be simplified to 3 over, only one person knows that? 3 over 4. We're dividing the top and bottom by 2, okay? So 3/4. So let's look at this. Does this seem reasonable? This says that the slope is positive. Does that slope look positive? Okay, remember we read our graphs left to right, so if there's a little creature crawling on this, there it is, going left to right. Is this creature going in a positive direction or negative? Positive. So yes, this is a positive slope. And 3/4 means that it's going up 3, and over 4. Up 3 and over 4. It looks like that, doesn't it? Okay, very good. So that is true. We were going to do it the other way as well. Let's imagine that the points are in, we named them in reverse. We have -2, -2. And we're going to call this one x2, y2 now. Instead, we'll call this one x1, y1. Because sometimes students don't believe that this is possible, but it is. So, where can I make room here? Let me slide these over. Okay, so if we do that here, we're going to use the same formula, right? Same formula, but now we're entering the points in differently. Okay, so we're going to start with y2, which is now over here, right? So who could say it? How are we going to input this? 4, Anthony?
4 minus -2.
Okay, over.
6 minus
-2. This is interesting. Okay, so let's just check to make sure we have points that are stacked. 6 under 4. 6, 4. Good. -2 under -2. -2, -2. Okay, do we all understand? Mm-hmm. We've now put them in, naming them different, like naming what used to be point 1 is now point 2. Okay, so let's change this to addition. Ready? We're adding the opposite, and we're adding the opposite. So what is 4 plus 2?
6.
And what is 6 plus 2?
8.
8. So now we have a positive divided by a positive, which is still a positive. And when we simplify this, we get 3/4. You see? You don't have to worry about which is point 1 and which is point 2. You just have to worry about having your points stacked correctly, okay? The other place that people can make a mistake is putting x over y. And so I bet you that will happen at some point to some of you. So try to remember that x is under y, right? And you'll be correct. Okay, go ahead and find the slope of these 3. Come back and check your work. Okay, here are the answers to 2 and 3. When somebody says the slope is 2 over 1, it could be written as the slope equals 2. And when somebody tells you the slope is 2, and you think slope is rise over run, then what do you do in your mind for the run? You put it over 1, right? A number like 2 always has a denominator of 1. Okay, and let's hear what your slope is here. Let's hear it together. 3, 2, 1.
-1.5.
I hear 2 different things. 3, 2. Did you not do this? Number
I
1.
did.
3, 2, 1.
3.
I hear 3 and I hear 1.5. Do you hear that? Which tells me somebody probably did that same error that we just saw. Okay? So let's do it. M equals y2 minus y1 over x2 minus x1. Just because they happen to be in order here, like this one's in the first and the second, I'm going to leave them in that order. Okay? So what is y2? It is, y2 is -1 minus y1 is 2 over x2 is
4.
and x1.
5.
I'm going to change this to adding the opposite. So m equals -3 over
-1.
-1. M equals 3.
I did it!
Good. Okay, find the slope of this. You're now given the information on a graph. Find the slope. Okay, so we simply make sure that we have 1 point. Here's a point, 3, 1. 3, 1. And the other point was -2, 2. -2, 2. And so in this case, again, we found a negative slope. There it is, going left to right. Going left to right, the little creature is going on a negative slope, going downhill, okay? That's reasonable. We should have a negative slope here. This also equals 1 over -5. I mean, if you're thinking of it in terms of rise over run, this first one here says I'm going down 1 and over 5, right? There's the actual, if I go down 1 here, 1, 2, 3, 4, 5, there. I've gone down 1 and a positive 5. This one here is saying I'm going up 1, so imagine going up 1, and then I'm going negative in this direction. You see, it's the same thing. Okay, so fractions are negative when the negative is either in the numerator or the denominator or even just in front. But if somebody gave me a slope like this, I probably would move the negative to the top so I could use it more clearly, right? Okay, so we can use this same formula to find the slope of our special case lines. So go ahead and use your slope formula to find it here. Okay, so we input the 2 points that were shown, and we got this fraction 0 over 5. 0 over 5 equals? I hear undefined and I hear 0. What is it really? 0 over 5 equals? It equals 0. Yes, it's true. It equals 0. The slope here is 0. M equals 0. No slope. Imagine you're at the bottom of a ski hill. You're on a flat land, right? You're not going up. You're not going down. You're flat. You're 0 slope. Okay? So horizontal lines have a slope that we can find mathematically. Here it is. It's a 0 slope. Let's try it with the vertical line using the same formula. Okay, so we have negative 9 over 0, and this is undefined. We have that stinky goose egg down below. No, it is undefined. And we've talked about how a vertical line is a free fall. It's just a free fall. It's all rise or all drop and no run at all. So it is an undefined slope. What if you're given slope, but you don't know where both points are? This is a fun question. Once again, we're not asked to find slope here. We're asked to find a missing part of a point. Do you see that? We're asked to find this second x here. So we start with our map again. There it is, the formula for slope. And what do we do, Rachel?
We fill in what we know.
That's right. So we say negative 1/2 equals, tell me how to fill it in here.
That's 7
Yes, so 7
minus 1
over
8
x minus 8. You said 8, but we don't have a point up here that is 7, 8, or 8, 7, 8, 7, right? So we have a point up here that is x7. Here it is, x7. We have a point that's 8, 1, and here it is, 8, 1. So now we're going to use what we practiced in the last chapter to find these things, right? Can we simplify any of these locations here? 7 minus 1 is?
6.
So my negative 1 over 2 equals 6 over x minus 8. We can't simplify x minus 8, but a fraction bar is not just division, it's also a grouping symbol, right? So group it and use your cross products. We have negative 1 times x minus 8 equals 2 times 6, which is? 2 times 6 is? 12. Okay, so don't forget, at this point, what do you have to do with that negative 1? Jeremy? Distribute it, right. What is negative 1 times x? Negative x, right? Negative 1x. What is negative 1 times negative 8?
8.
Positive 8. And now you simply solve, right? How would you solve this?
Subtract.
And Chris?
You subtract 8 equals 5.
You get negative x equals 4
And then you divide
by
-1.
negative 1. And you get x equals negative 4. You've now found the missing piece of the point.